Okay. And alrighty. Welcome everyone to Programming in C. Hopefully if you've got exams this week, how many people had exams today? Probably a few of you. Well, I hope you've did well with them. And if you set my exam, I didn't create too much pain for you. Anyway, so let's get right into the course. So just a bit of a word on prerequisites. At a minimum, bare minimum, you should have completed Programming 1 or a similar introductory programming course. Now, there are a few things which might be advantageous for you to have, but if you don't have them, that's okay. We'll figure these things out as we go along, and I'll do my best to be as supportive as possible along the way. So, for example, if you've done any low-level programming, that not just assembly, but there's languages like Rust and maybe even Go or something like that, that they would all be advantages, but not really required, or not required at all. Likewise, a little bit of familiarity with the with Linux and the command line would be awesome, but you're going to be spending this week kind of becoming familiar with those things. So that's neither here nor there, but certainly if you did well with Programming 1, you're off to a good start with this course, although C is generally because it's more low level, it's basically high level syntax over so it's like having Java like syntax, but it's actually assembly programming on the machine, so it can be a bit of a challenge your first time round. In fact, I would be very surprised if it's not a challenge, so just expect that. So this course is really what we want to teach you is modular programming, and basically to highlight the programming principles and techniques you would use for programming C for modern C programming. We are using the ANSI C standard, which was developed which was adopted in 1988, but there have been lots of improvements in compilers since then that in fact will be advantageous for us as well. But the syntax is the syntax which was adopted in 1988, but the language is a living language, and in fact it's less than 5 years ago that the last C standard was put forward, and it's likely to be in about 3 or so years that the next C standard gets adopted. So that's, yeah, it's not a dead language, it's very much a living language. I guess one of the things here is that getting good at programming will require effort. Who decides the standard? I'm really glad you asked that, Bradley. It's actually a committee of the International Standards Organization. In fact, if we I'll just jump into a web browser here. come on, be nice to me. Oh yeah, that will do me. And ISO C. And so it's the ISO. Well, basically, it's you can find out stuff to your heart's content about the adoption of C and where it's at and so on. It's all done via the Open Standards Organisation. So that gives you a bit of a flavour for who makes those decisions. And generally speaking, the people who are involved in that committee are people who are developing C programs, big C programs. You know, things like, for example, operating systems. And what their needs are tend to get reflected in what gets adopted in the C standard, although there's lots of debate and it's actually can get quite fiery. Like, for example, what does the Linux community want in the next version of C, or that kind of thing can be rather important. Okay, so that's the C standard. I might just keep that browser open in case I need it later. But essentially, practice is the key. And the more practice you can get, the better. I'm of the view as well that because C and Unix are essentially parallel technologies, well, basically the team who created Unix then created a operating system that would be easier to develop an operating system in, being C, that the two technologies go hand in hand and the concepts transfer across from one to the other. So that's one of the reasons I encourage people to be developing stuff in C. Developing stuff using the Unix terminal, but that's not compulsory. You will actually develop a tool set, or you'll use a tool set which you're comfortable. But I also think that the more flexible we are as programmers, the more jobs we can apply for. So, yeah. So, how much work should you expect to put in? Well, I would say about 8 hours outside of class. Okay. In terms of the topics that we're going to deal with in the next 12 to 13 weeks is, well, we've got today's course overview, and we'll start a little bit on C data structures, very small. Next week we'll focus on C data structures. We're not so much going to worry about software design principles, but we will talk a little bit about top-down design, that is, breaking things up into functions and why that's important, but also what are the costs of functions. String and string manipulation. So that's about the first 3 weeks, what we've got there. Then debugging skills. There's heavy emphasis, including an assignment component. So the first part of assignment 2 will in fact be a debugging assignment where I give you some broken code and I say, well, here are some tools. Now you need to fix it. And you'll submit some reports, a very short report, like half a page each at the most, describing how you found the bugs and how you fixed them. And you'll get bonus marks for using the tools which we recommend. So that's an important part of the way I run this course. and I've got lots of good feedback about that. Then we'll have a look at file processing, and then dynamic memory management, and we're going to be looking at linked lists and dynamic arrays. And we'll finish off on generic programming skills. I think I'm actually going to remove the stuff on external libraries just because there's so much in this course already. It just puts a load on your minds that basically most of the real world code involves the use of libraries written by somebody else. And so I certainly think when you're going beyond this course, you want to be looking at what libraries are out there and how you can get them to do some of your work. On plagiarism, well, we've always got to deal with this. Don't submit an assignment which has sections copied from another student. Don't submit an assignment in which any portion has taken from a source you have not credited. I am familiar with web search tools, and I'm also familiar with common sites that people go to try and find answers for assignments and so on. So, you know, I'm not an idiot and don't treat me like one. We'll also run your code through a plagiarism checker, which basically compares your assignments with each other. For more information on academic integrity, go to this website, which is the university's official spot on academic integrity. So, where do you learn? Like, what kind of learning opportunities do we provide to you? Well, these sessions, the lecture and practical chat, are your main contact with teaching staff, i.e. me. And the practical chats in particular are essential to get the maximum out of the course. To attend or watch the recording or whatever, but basically to do the exercises, learn programming by doing programming. The assignments, basically the way I've actually structured the material is so that there is no wasted time. Everything builds towards your assessment, and your assessment builds towards the skills which a good entry-level C programmer should have at the end. And in fact, those skills will help you with any programming. The discussion forums, so they're your main point of contact. You'll need to check them fairly regularly. Don't ask me questions via email that could be answered on Blackboard, basically. Because if you ask me those questions, I'll just forward them on. I'll just say, hey, can you ask that on Blackboard? You're welcome to send me an email about your personal situation if that is relevant to your assessment. But anything which others might benefit from the answer to, I'm going to ask you to post on Blackboard. Okay. And might come back to, okay. I often get asked, well, what text editor or IDE should I use? To be quite honest, I'm not too fussed. I believe that that an important part of learning C is actually learning the concepts which underpin Unix, because a file in C is related to a file in Unix. That they are very interlinked concepts. So I recommend using Vim or Emacs and actually spending time this week getting to know one or the other. And the course materials I've provided help guide you in that direction. Now, I've had people say to me, is this a Unix course? No, it's programming in a Unix environment. So you need some basic skills at being able to copy files, edit them, compile your programs and so on. But nowhere near what you actually would need if you're using Unix for anything beyond programming, like on a daily basis. Although I recognise a number of you from Unix system administration course, so shouldn't have any problems with that stuff. Those of you who are, yeah. I do encourage you to explore other development environments, but I think it's important as a student or as a worker beyond study that you can just move into whatever environment you need. It shouldn't matter, oh, I'm a Windows user, well, here we use a Mac or here we use Linux. You go, okay, cool, let's go with it. It just shouldn't matter. It's a good strategy for, you know, the workplace to actually be flexible with the kinds of environments you can work in. Okay. Now, I'm not really going to go too much into the history stuff. I provided you a video in the course materials for this week, which actually talks a bit more about the history behind Unix, so the history behind C, and why it is a pretty, what we call loosely typed language. And that's because it was developed from BCPL, which was an untyped language. And so people like Brian Kernighan, Dennis Ritchie, Ken Thompson and so on, they liked a lot of things from BCPL, but they didn't like the fact that it didn't have a type system. So that's one of the things they brought in, but it's a very simple type system, and that is something that you might struggle with. Like, for example, Java is much more strict, and so you might struggle with that difference, that the type system is fairly loose. But like I said, it's a programming language which has been developing quite a bit over time. So we had the C89 standard, and then in 1990 there was an internationalized standard, and that 1990 standard is typically what's called ISO-C. But we're going to use ISO-C and ANSI-C as interchangeable. So it's that standard which was developed, which was adopted between 88 and 1990. Okay, so just getting C was basically it's a combination of structured programming laid upon a low-level interface, and essentially you're writing in C programs get converted into assembly language, so they get converted into the language specific for the machine. and therefore there is some difference in behavior when you run C programs on different computers. Now that's another reason why it's probably not a good idea to develop on one machine to deploy on another, because the bugs might be different. Okay, that's something to think about. And that's why we give a single deployment environment. Okay, so why are we going to study C? Do any of you have your own reasons for wanting to study C in particular? Cool, yep. A lot of embedded software is actually written in C, and C is really the best language for that stuff. Ah, yes, definitely. If you can develop something in C, you can pretty much develop it in any other language. Yes, that kind of low-level stuff like what James is talking about here, digital signal processing, which is about audio. If you're interested in games, that might be another reason if you want to do games development. Still a lot of that happens in C. Operating systems. Also, you learn a bit more about how memory works, how the hardware underpinning your environment, how that works. Yeah, and yes, every language you learn makes things easier, but also C, I'm expecting C will change how you view your programming in every other language. Because fundamentally, at some point when you go down the stack, when we're talking about full stack developers, where they're doing stuff on the machine or they're doing web stuff or wherever, every language has a component which is written in C, which does the low-level machine operations. And pretty much every operating system is written in C. I think, say for example, Windows is developed with a combination of C and C++. Yeah, it's the language which gives you the most freedom and therefore the most dangers when you do it badly. But we will show you tools to cut down on the negative and up the positive. Yeah. Okay. So, looking at application areas, which we've essentially been talking about, AI, databases, and graphics. In fact, I wrote a database system, or at least the indexing component of the database system using C. Because real database systems are written in C. Oh, absolutely, Aaron, never fear about that. Although that's the second half of the course. We're going to, in the first half, be pre-declaring how much memory we want. Say, for example, by the use of fixed size arrays and that kind of thing. And we won't worry about any of that dynamic stuff. We'll learn the basics, and then we'll have a step up and actually learn the more complicated stuff around dynamic memory allocation and all of that. Yeah, embedded in real-time systems. Anyone heard of Arduino? Yeah, well, Arduino, basically you write the programs to manipulate microcontrollers in C. And it's just very much a plugged together kind of framework. So you plug together whatever device you want, and then you provide the firmware code to make it work. That's all done in C. And that's part of what we call the Internet of Things, which is a really big growing area. And I think that C is probably one of the better languages for exploring that stuff. Engineering and scientific applications, yeah, there's lots of old software in particular written in C for kind of scientific applications, and that stuff needs to be maintained. A lot of that would in fact these days probably be more written in C++ than C, is my view. But yeah, so looking at types. So C has a very basic type system. So here we can see that we have ints, we have long, we have char. Okay, I'll stop with those three. Now, you've probably used those in another language. What's the difference between those three, do you think? Correct. And in fact, that's the only difference. What I mean is that int, long and char are just ints of different size. That's all. So we use chars to represent characters. But that's just because the ASCII table has 256 entries. Well, a char is typically 8 bytes, so we have 8 bits, so we have 2 to the power of 8 different values it can hold. So it's ideal for a system which is specified to hold 256 different values. That's all. And so we can in fact print out the same thing as an int or as a char, and we'll get something different. I'll just show you very quickly what I mean. So I've got this program, charbell.c, and I'll just include it. Include sand.io, sand.io.h, and include standard lib.h. Every program you write pretty much will use those two headers. The standard IO header file describes input and output operations, and the standard lib just the general standard library provided by C, so the C standard library. So what's on the left hand side is an int, and what's on the right hand side is an int, in fact. So I can printf. So I'll print it as a character. I'll insert a tab and I'll print it precisely. That's exactly right. And I'll print it as an int. I also often get people ask why it's success. Why can't I just put 0 here? Well, not all systems have success as 0. And basically what you're doing is you're sending a message back to the operating system to say everything worked well. By using exit success and its partner, exit failure, you have consistent behavior. Alrighty, GCC ANSI. So we're using the ANSI standard. Show all warnings. Pedantic. Charvel.c. You'll need to compile programs using these flags. We want anti, pedantic, and wall. So pedantic really just means the full C90 standard. Okay. The Unix philosophy is if you don't have anything bad to say, don't say anything. So this worked. Now, if you have a look up the ASCII table, such as using and we'll make that a bit bigger. And then we'll scroll down. I might just make that a bit wider. Oh, look at that. A. 97. So, yeah. Okay. Question from Sam. You said yes, it does convert correctly, but a float will have its fractional part cut off, or what we call truncated. There is actually another issue with floating point numbers, and that is that they shouldn't be used for anything where accuracy to that number of decimal points is actually required, because there is some rounding that occurs. But that's a different issue. Like if you want 2.3 to always be exactly 2.3 and not 2.29 or whatever, then floating point, that is float or double, is probably not a good choice. And we have other options in that case. Like we might have a pair of values, one for the part which is greater than 0, so one for the whole number part and one for the decimal part, and have that as 2 ints, because they are both ints are accurate. but floating point numbers give us a range which isn't possible. Okay. So then we have float and double. Now, all I'm going to say about float and double is that the difference between them is how accurate they are. Because essentially, the difference is we give double twice the bits. So a float is typically 4 bytes, and a double is typically 8 bytes. So it has twice the bits, which means we can get a much more accurate representation of that same number. And C also has a type to represent nothing, and it's the void type. So if we want to actually write a function that returns nothing, we specify void, and that should be pretty familiar from previous programming languages. You can't compare void, you can't assign void, but it's just a placeholder for meaning nothing. There is an exception to that, which is void pointers, which we'll get into later, which is can be a pointer to anything. But let's not get into pointers quite just yet, because they are a lot of fun, or trouble, depending on your perspective. Okay, so here are examples of the kinds of values that we can have. Something I want to actually point out is, in fact, there is an unsigned int as well. So really all that means is normally with an integer we have 30, say for a 4-byte integer we have 31 bits for the value and 1 bit for the sign, right? With an unsigned int we get that additional bit, so we now have 32 bits for the value, but we can't represent negative numbers. That's quite useful, although one of the reasons why I won't be using unsigned so much in examples is, in fact, they're slower on most systems. Something I actually only found out a few weeks ago, actually. But anyway, so here we have 3 minus 6. What's this 077? What's the 0 at the start supposed to signify, do you think? Yeah, it's octal. Yeah. And then we have, so that number there is 7 eighths of 56 plus 7, 63. What about this next one? OX3F. 0x3F. Hex, yep. And what about this last one? Oh, minus 3, sorry, 3U. Yeah, it's an unsigned number. Do you think... Oh, I was doing my thing. Why is what do you think about this number? You think that's valid? Minus 3u? And in fact, you know, the fact that I've asked it means that the answer is going to be yes. And Sam's good on you there, yeah. It is a really big number. Because what happens is we wrap around, you know, we have the representation for minus 1 in binary, which is all ones, right? 1, 1, 1, 1, 1, 1, 31 ones. And minus 3 is simply 2 greater than that. So we add 2 to that. But then we treat it as an unsigned number. So it's right up the other end. And so this is a trap. If you've got a for loop, for example, and you're counting downwards to 0, don't use an unsigned number. Because if you do something like I is greater than or equal to 0, well, it's always greater than or equal to 0. There is no time when that would be false. So that's a trap I've fallen into myself. So, something to avoid. Yep. So we've got these characters here, or these chars, A, Z, /n. Anyone know what the /n is? Is it one character or two? It's one character. We use 2 characters to represent it because we have no way to represent it using our normal characters. But in fact, it evaluates to a single character. So does this 004. And this one here is pretty special. /0. Anyone know why that's special? Almost. Yes, it's a string terminator, but it's not actually. So we have something called null. And that's a pointer to the 0th address. But we have something called null, N-U-L. Which is the character 0. And in fact, if we go back No, not that one. Where were you? Yeah. It's in fact zero terminated strings, which is what strings are. They're zero terminated. But we'll come back to that point. Okay, floating point numbers. We can, so for floats, we can specify F, and that says that it's actually not a double, because by default, floating point numbers are double. That is, they're 8-byte representations. Whereas the F means that it's a float. What about this last one here? What on earth is going on? 1.1 E0 to... Ah. Yeah, correct. Scientific notation. And so what it means is 1.1 times 10 to the minus 2 in this case. No, 11 times, no, 1.1, yeah, times 10 to the minus 2. And when we leave off the F, they're double values. So they all occupy 8 bytes. Okay, then we have void. So for example here, I have a function declaration. I have a function that returns void called doIt, and it takes no parameters. So that's an example of where you would use void. So there may be some loss of information in conversions. Like for example, when converting from double to float, we actually have the number of bits, therefore there's a lot of information that we have to throw away. Actually, I'm glad you asked about that particular question, because you don't, except it means something different. This does not mean, that does not mean accepts no arguments. It means the arguments are unspecified. So there are times when this will be more acceptable to the compiler and it will work in more situations than this does. I prefer to specify void because it makes it clear this function takes no arguments. If you leave it out, it means something slightly different. Okay. So C does many implicit conversions. And in particular, if a compiler warns it's just a more clear contract, because a function prototype specifies a contract, and If you delete that, then there are more functions which can match that contract. That may be not what you want. Yeah. Okay. Don't ignore your compiler output, even if the program compiles, because the warning may be a serious warning. Treat all warnings well. There are some that you can, okay, I have an unused variable right now. Well, I can fix that by using it. But there are more or less serious warnings, but you need to take them into account. Just because your program compiles doesn't make it safe. And so, let me just, I've got some lectures. Well, I've actually got some the source code for these lectures is available. Oops, try that again. Okay, so these are available in shared lectures. This is under my home directory. You won't be able to CD into, say, that directory on its own. It's the full path. Alright. So, week 1. And let's have a look at this printf warning. Oh, that hasn't come out very well at all. I'll change that. And it's currently, we'll change that to, let's see how Cyberpunk works out. Okay, that's a bit better. So, what I want to do actually is I want to show you something that I've seen students do before. Okay, I want to print out a number, printf I. Now, let's just see what no, it's 5. Well, it's only when talking about out. So let's have a look. Well, it's just 5. What we want is the character that represents the value of 5 to be printed out. But currently, if we just compile this, GCC ANSI all pedantic printf warning. Okay, so now we get a warning. Passing argument 1 of printf makes a pointer from integer without a cast, and then it actually provides me with information about the declaration of printf. It expected a char pointer. Well, it expects what is called a format string. And what happens is it doesn't find a string. So what it does is it treats the number there as a memory address. Can you see how this goes wrong? What if I run it? What do you think will happen? Because it compiled, there's a warning. What do you think will happen if I run this? Something hinky is probably good, yeah. But the memory address 5 is in fact likely to be a memory address you don't have access to. It's likely to be one owned by the operating system. And so it goes, no, you can't have access to that. And that's what that segmentation fault means. You're trying to print the contents of memory address 5. But that's not a memory address you're allowed to have access to. So, let's fix this. Okay? Okay, so that's correct. I'll just finish off here by showing you a bug that I inadvertently created for myself the other day. Format equals now, it's what's called a format specifier. And %s is for a string, %d is for a decimal integer. But looking at that code I've got there, therefore, what's going to be my problem? Well, it's this format I've specified up here. Remember I said %s specifies a string, which for now, let's just say that's a memory address. We have the same problem again, except now we no longer have a compiler warning. Oh, yeah. Don't worry so much about that stuff right now. We will get on to, like, for example, what the star is and all that kind of stuff in very soon in the course material. But it just it's what's called a pointer. But so that's still a string. So if we and we're back with our segmentation fault. So I'll just replace that now. D meaning for decimal. And that works. Okay. yeah, that's exactly the issue. I mean, it's a little bit more complicated than that, but we'll get into that complexity soon enough. No rush. So, what we've talked about so far is simple types. That is int, float, double, whatever. But what if I want to package something together? So I have several things. Like, for example, I have a student. Now, a student might have a student number. They might have a list of courses they're enrolled in, and they might have a list of courses they've completed with grades for those courses, right? Now, for that kind of thing, we use something called a struct. Now, a struct is essentially an object. Has everyone programmed with objects before? Yeah. So there are some complexities which go with structs in C, but basically they're objects. They're similar kind of syntax, but there's some additional stuff. And then we've got something called an enumeration. So, for example, if you wanted a data type which was to specify the day of the week, that's what that's for. So you've got a series of constants you want to define. Now, our unions, I just mentioned here, we won't come back to them really in the rest of the course, but I feel that we should just mention that they exist. Now, a union is when a variable can be well, the question of the first day of the week, you can decide that by how you define your structure. A union is where, for example, I have something like a vehicle. Now, a vehicle can be a car, a bus, or a motorcycle. But we only want to assign to one of those variables. Yeah. And so we would use a union. And the amount of memory that that union takes up is the size of the largest variable that's part of that union. Basically, unions are like structs, only one element exists. So, we're going to go into this stuff in a lot more detail next week. I just thought that you might want to, just give you a bit of a start, a bit of a warm-up this week. Now, what might be useful for you is once you've gone through the basic Unix stuff, so that's the key thing I really want all of you to do this week, is if you're not familiar with Unix, then go through the material that we've provided to warm you up to that. You're going to need that in order to compile your assignment. You won't be able to do it otherwise. You will be required to compile your program the way you saw me do it today where I use GCC, ANSI, wall, pedantic. Then I had my C source file. Then I had a -o and the name of the executable. And then I ran that by calling // and the name of my executable. You'll get some practice with that this week and next week, so don't stress too much. So what I would do is in your home directory, there is a program called LN, which means link. So I'm going to link say I'll call that PIC shared, right? Now, if I have a look in PIC shared, that's all the files that I share from my account. So you just do that using this command, and then all of the material that I share will be available to you from that directory. You'll need to copy it to somewhere where you have the ability to edit it before you can edit it. All the files in here will be read-only. Okay? Okay.